In addition to the phrase error term, which is what we call the ANOVA, estimated standard error, there are some other terms and notations unique to ANOVA that you will be using. We use the term factor to identify the independent variable, and the term level to identify the treatment conditions within the factor. Figure 12.2, shown on the slide and also on page 348 in your book, provides an example of a research scenario that shows a research design with two factors. One factor uses two levels of therapy technique, 1 versus 2, and the second factor uses 3 levels of time, before, after, and 6 months after. The ability to combine different factors provides researchers with the flexibility to develop studies that address scientific questions that could not be answered by a single design using a single factor. In Table 12.1, shown on the slide and also on page 351 in your book, are hypothetical data from an experiment examining driving performance under 3 telephone conditions. Notice that even though the scores within treatment groups 2 and 3 are very different, both treatment groups have the same mean. It's impossible to tell if there might be any statistically significant difference between the handheld treatment group and the hands-free treatment group with respect to driving performance. One might think that you could simply calculate a series of t-tests, comparing treatment 1 with treatment 2 with treatment 3, and treatment 1 with treatment 3. However, each of the t-tests would be done using an alpha of 0.05. Over the course of calculating several t-tests from the same data set, you would run the risk of making a type 1 error. ANOVA allows you, in one overall test, to compare the variance difference across all the groups. The first step is to determine the total variability for the entire set of data. To compute the total variability, we will combine all the scores from all the separate samples to obtain one general measure of variability for the complete experiment. Once we have measured the total variability, we can begin to break it apart into separate components. The word analysis means dividing into smaller parts. Because we're going to analyze variability, the process is called analysis of variance. Continuing on with the same research scenario as shown on the previous slide, you see the hypothetical data from an experiment examining driving performance under 3 telephone use conditions. Only sample statistics have been computed. Some of the notations will be familiar to you, but there are some new ones to learn because there are more moving pieces within an ANOVA, and we need a notational system to keep track of all the individual scores and totals. The letter K is used to identify the number of treatment conditions, that is, the number of levels of the factor. For an independent measure study, K also specifies the number of separate samples. The number of scores in each treatment is identified by a lowercase n. The total number of scores in the entire study is specified by a capital N. The sum of the scores, sum of X, for each treatment condition is identified by the capital letter T for treatment total. The total for a specific treatment can be identified by adding a numerical subscript to the T. The sum of all the scores in the research study, the grand total, is identified by a capital G. Although there is no new notation involved, we also have computed sum of squares and mean for each sample, and we have calculated sum of X squared for the entire set of n equals 15 scores in the study. Note that there is no universally accepted notation for analysis of variance. Although we are using capital G's and capital T's, for example, you may find that other sources use other symbols.